I'm Shadil Shahul Hameed. Today's Tech Talk is about present and future of mobile application testing. Day by day, mobile applications are becoming complex. So, mobile applications becoming a critical part of the application development. Let's see the agenda. Why mobile application testing? What is mobile application testing? Then types of mobile apps, different types of mobile application testing. Writing a common test case for mobile app testing. Mobile display keywords useful for bug reporting. Then mobile application testing tools, manual and automation. Present practices in mobile application testing using AI. Mobile application testing future with artificial intelligence and machine learning. Finally, myths in mobile application testing. We will start with why mobile application testing. Is it okay to use the same web application testing techniques for mobile application testing? Answer is no. 6.64 billion users and 83.32% of people having smartphones in the world today, and 119 mobile brands available in the world today. An average of around 24,000 malicious mobile apps are blocked daily on the internet. And mobile phone is a portable device, variety of devices like different chipsets, screen resolutions, and phone brands, different mobile network bands and network conditions, like different variety of operation systems and frequent software updates and many interferences. Mobile internet usage continues to rise day by day. Technologies of mobile phones changing and growing continuously. Even users are trying to accomplish their needs by using a mobile phone rather than spending on devices like laptops and expensive devices. Users spend an increasing amount of their time on mobile devices. It is critical to provide a good experience on your mobile applications. If you are not testing the mobile experience your users are receiving, then you can't know how well your application serves large number of users. Next, we will talk about what is mobile application testing. Mobile application testing is a process by which applications for modern mobile devices are tested for functionality, usability, performance, much more to meet all business requirements as well as user expectations. Basically, we can use automation or manual testing methods for mobile application testing. Next topic is type of mobile apps. There are three types of mobile apps like native apps, responsive web apps, hybrid apps. Native apps are designed specifically for a particular mobile platform and generally download and install via App Store like Apple App Store or Google Play Store. Responsive web apps are designed to be accessed on a mobile browser like Chrome or Firefox. Web apps can be either responsive version of a website or a progressive web app, which adds additional mobile-friendly features. Hybrid apps are designed as a compromise between native and web apps. Hybrid apps can be like installed via App Store just like native apps and may have some native functionalities, but at least partially rely on operating essentially as web apps wrapped in a native shell. Next topic is different types of mobile application testing. There are different kind of testing types. When we consider mobile application testing, we have some specific testing types like functional testing, performance testing, security testing, and exploratory testing. Those are common for web application and mobile application testing as well. But usability testing and compatibility testing, installation, uninstallation testing, interruption testing, memory leak testing, and network testing are having specific mobile application testing characteristics. Today we will discuss more about these mobile application testing types. First, I will start with network testing. Mobile apps do strange things when networks are slow or out of coverage. We have all experienced it at acting up when try to use in a place like elevator, subway, or underground parking, like no coverage or less coverage areas. Another example, when user is in Wi-Fi area and while using the mobile application, if the user moves out of Wi-Fi area, then data connection will be switched into mobile data. In that case, mobile application could show abnormal behaviors, and we need to test the application in various network modes like WCTMA, LTE, 5G, Wi-Fi. So network testing is a critical test in mobile application testing. Second topic is compatibility testing. Compatibility testing ensures whether the mobile app is working and compatible with all the different types of mobile devices you aim to support. This testing is also crucial because standard usage and performance of the app is upon various devices, operating systems, hardware, browsers, and different versions and different screen resolutions. It should be compatible with all conditions. Next, we'll talk about usability testing. Testing mobile applications check for good user experience, good standard layout of the UI and user ease of use. If we take some example, if the buttons are small, it is not easy to touch the button. When there are like alignment issues, small font size, user might feel bad impression on the app. Using the same theme everywhere, clickable buttons, readable font sizes should be tested according to the user experience. This is usability testing. Fourth testing type is localization testing. This type of testing is specific to a mobile. We test the ease and success of installing an application in various environments like in mobile data, Wi-Fi, GSM, LTE, WCDMA. This also means that we need to check the uninstallation process. Delete all related files when uninstalling the application from the device. Next is interruption testing. This is the type of testing which is very important for mobile device because there are several interruptions that can occur during an app use on mobile device like SMS, internet disconnection, device getting auto-locked while using the application, incoming outgoing calls, notification, alarm, low battery notifications, connecting charger or headset. Like these are some famous interruptions we can find in a mobile device. Next testing type is recovery testing. During recovery testing, we test how well the application copes up with a failure and starts working again. Like failures can be like software failures, connection issues, device hardware issues. Final testing type is memory leak testing. Most of the Android applications are coded in Java. Fortunately, Java has its own garbage collection which frees all the memory which is unnecessary and unused. At times, there can be some scenarios where the previously used memory is not deallocated. Hence, the pile of unused and occupied memory keeps on increasing. This causes application to crash because of less memory at disposal. This phenomenon is called memory leak. Memory leak testing, like we can use white box techniques at the code level, and we can't use black box testing techniques for memory leak testing. Also, it is better to unit test the application to catch the memory leak early in the development cycle. Now we will talk about a much important topic, writing a common test case for mobile app testing. When we are writing a test case for a mobile application testing, apart from functional test cases, we have to consider these test cases as well, like interruption, like example calls, SMS, notification, shutdown, restart, like scenarios we can consider. And battery testing the application in high power consumption mode, battery saving mode, like those are some examples. And testing the application while charging the mobile phone, RAM usage, installing and launching process of the application, uninstalling the application, updating the application. These test cases we can run in test environment or App Store, Apple Store or Google Play Store conditions. And screenshots and screen recording. If you are testing a bank app or finance app or any app like containing confidential informations, we have to test this behavior of screenshot and screen recording. Usability. Usability, we can consider some examples like button size, whether buttons are clickable, fonts are readable, etc. Then dark mode. Dark mode, we have to check in application dark mode feature and application behave with the mobile operation system dark mode, because in dark mode some apps might not be supporting. Still, mobile OS is supporting dark mode, so there can be like abnormal behaviors in the application. In application UI behavior, mobile OS text size, font size, and screen refresh rates. Because screen refresh rates depend on the mobile phones, it can be vary like 90 Hz, like 120. And application loading time in a user perspective way. Like as a user, we can test the device and check the loading time. Is it a considerable time or it is already, or else it is taking too much time. So it for mobile application testing. We will share the document soon. Then you also can use that document for mobile application testing in future. Next topic is mobile display keywords useful for bug reporting. When reporting bugs, it is good to know about the mobile display keywords. If we use the correct wording, developers could understand and locate the issues quickly. Like this is the home screen, notification panel, this is the lock screen, and this is the smart sidebar, then quick settings panel and notch area. It is an important part, notch area. Then this is the status bar and this is the navigation bar. Navigation bar have like recent task button and the home button and the back button. Next we will talk about mobile application testing tools, manual and automation. There are so many testing tools, but we have to select the best tool meets the project requirements. Here I have showed some famous tools like Hobbiton, Test Trigger, AccelQ, Catalan, Perfecto, Test Grid, Appium, and Selenoid. When we are selecting the tool, we can consider the tool according to the supported platforms like iOS and Android, supporting testing types, automation testing or manual testing, other tools that we can integrate with, supported frameworks, real device capability, and cross-browsing capability. According to that, we can select the optimum tool for our project. Some are supporting AI, artificial intelligence as well. Now we will talk about present practices in mobile application testing using artificial intelligence. We have already seen new mobile testing tools that have adopted AI, provide easier test creation, simpler test analysis, and reduced test maintenance. First, we will talk about improved element location. Current AI-powered mobile testing tools employ visual locators to eliminate the need for these fragile selectors and provide a more robust way to targeting elements. Instead of hard-coded selectors, visual locators identify elements based on their visual appearance. This way, even if the selectors for the elements change, your test will still work. Like Applet tools use its suite of visual AI algorithms to identify visual elements. Test.ai uses a reinforcement learning model called Q-learning, in which bots learn how to navigate your app and recognize elements. Catalan uses a visual object recognition model to recognize elements. Second point is self-healing test. One of the major frustrations associated with the test automation is false positive. When a test case fails but there is no bug and the functionality that tested is working correctly, false positives make automation tests less reliable. Thanks to AI, some mobile testing tools now possess self-healing abilities. These tools can automatically identify the change made to an element locator or screen flow that was added between predefined test automation steps and quickly fix them on a fly or alert and suggest a quick fix to the developers. Like Qmetry has the Qmetry Automation Studio called QAs, which uses self-healing to evaluate the test status, identify problems, analyze the situation, and automatically suggest a solution. All a user must do is either approve or deal with the suggested fixes. Third point is validation. Visual testing is the process of evaluating the visual interface of an application against the results expected by design. In order to detect inconsistencies in appearance, traditional testing tools use the underlying structure of an application's DOM to determine the status and presence of visual elements. To test visual interface this way, you would have to write thousands of assertion code lines to cater the different variation of operation systems, browsers, screen orientations, screen sizes, or font sizes. This method is highly inefficient, brittle, and just contributes maintenance burden. Modern AI-enabled testing tools use visual validation feature to effectively uncover visual inconsistencies by comparing baseline snapshots of app screens with the corresponding current screen on every regression run. These tools can identify elements and rendered screens and compare them to snapshots of the same screens in their expected state using a class of artificial intelligence algorithm called computer vision. Like Applet tools use its visual testing API called eyes to compare snapshots. Hobbiton uses its Nova AI engine to compare snapshots and propose UX optimizations. Fourth point is improved scriptless or codeless test automation. Traditional mobile test automation tools require you to write code in order to automate test scenarios. By incorporating AI, modern mobile test automation tools have evolved from prominent record and playback method to further simplify the process of creating and maintaining tests. Using methods such as natural language processing (NLP), where you can use plain English-like statements to create test cases. These tools make easy to create, update, and maintain tests. Like test.ai uses AI bots to try to understand how a user would use a mobile app and then test it accordingly. It is mostly focused on user experience. And Test Sigma using NLP, Test Sigma allows to create test cases by writing plain English statements. These simple statements are then converted within the tool for execution. Now we will talk about mobile application testing future with AI and machine learning. We will talk about two main topics. Like first topic is automated and intelligent gap analysis. Gap analysis in software testing is the process of identify untested new code within the application. As modern mobile apps become increasingly complex, it is easy to miss the test in some application flows. Untested code is far more likely to contain bugs than tested code. In the present, for gap analysis, use a combination of static analysis of all code changes and dynamic analysis of current testing. This effort is intensive and time consuming. With AI, future mobile testing tools can learn how users are interacting with your app. If the system sees lot of people are taking an untested user journey, it can alert you that there is a gap in your testing, so you can take care of it. These tools will also be able to highlight which areas you should focus your testing resources on based on your usage intensity. This way, teams will be able to optimize test coverage even with limited resources. Second topic is automated test generation. Existing mobile test generation, that is automation tools, only deal with automating the execution of test. But simply automating test execution is not enough when taking hours, week, or like even months depending on the task. As AI technology continues to advance, we will hopefully get to a place where unit and API test generation is very mature and mainstream. So developers and testers alike can focus on innovation and creativity. My last topic is myths in mobile application testing. Testing application on emulator or simulator is adequate. Like performance testing is not possible in emulator or simulator. Like if we consider some examples, battery drainage, overheating, like screen visibility in outdoor conditions are not possible to test in simulators or emulators. The second point is visual appeal is more important than the actual features. App design and ease of use also need to be user friendly, but functionality of the app should be as per the requirement, or else user will not take much time to uninstall the app from the mobile. Third point is one device each of Android and iOS is enough to test. iOS and Android devices released on regular intervals. There are different OS versions, screen resolutions, chipsets. So testing few devices will not be sufficient. Fourth point is mobile apps are already tested security by Google and Apple. There is a myth in developer community that Google and Apple deeply test the mobile applications before they are made available on Play Store or Apple App Store. In reality, this is not the truth. Both Google and Apple provides frameworks and tools for the developers to create secure apps. However, they do not check for the data leakage, vulnerabilities in third-party libraries, or privacy issues. Fifth point is no need to do the network testing. Mobile apps that work in a client-server mode face connectivity challenges due to like exponential increase in data traffic coupled with unreliability of networks. And mobile apps are expected to function in various networks such as Wi-Fi, 4G, 5G, 3G network. So network testing is a must in a mobile application testing. Testing mobile application using web application testing approach. Most of the projects QA teams like work on both web and mobile applications. Some core concepts of testing mobile app testing require different approach. One must understand mobile app is completely different from web app. Mobile users are on the move rather than front of a stationary computer with a fixed location. And web applications are built in bigger screens, whereas mobile applications are optimized for smaller screens. As we discussed earlier, we have to use mobile application testing techniques. This is the end of the today's tech talk. Thank you very much for joining.